how we can utilize Int Fold server for integrated protein structure and function prediction. This little tool is a very unique server within bioinformatics, which is very commonly utilized within bioinformatics analysis, as compared to other tools such as Swiss Model, Modeler, and Weight Center, because those tools are some older tools as compared to Int Fold. Int Fold is a server that is maintained by University of Reading, and it has various features and allows you to do trusted structure prediction, which also means as 3D modeling, 3D structure prediction. And it automatically then does 3D model refinement and quality assurance, and you don't have to do evaluation from any other tool. It will automatically do itself. Then it will try to predict the disorder prediction of the protein. Then it will predict the domain boundaries, and then it will finally predict the protein ligand binding residues, where a binding site of the protein where the ligand could attach. So all of these predictions are done by this single tool, single server. You just have to provide in your protein sequence, and other than that, you don't need to provide anything else. It will automatically predict all of these things by yourself and then present you the results. But there is a downside for this. It does not do it on a rapidly basis. It is priority based tool. For example, if you provide in your protein sequence, it will take some time, about 24 hours to 48 hours, or even 72 hours in some cases, and so that you can get your results back on your email address that you provided during the input process. So you have to wait in this process, but as the saying goes, the waiting actually is fruitful in some cases. So this is the page that you can find within the transcription. This is the link that you have to go and make sure that it is updated version. Currently we are on the 5th version of Int Fold, and it is basically an integrated protein structure and function prediction tool. It is not just a protein structure prediction tool. So all you really have to do is providing your protein sequence. I'm utilizing the AKTBL1 gene and of Homo sapiens, and just providing the sequence in any format. It can be just a single letter code, it can be FASTA format, and just make sure that you don't include then the FASTA identifier. This line should not be included, and other than that, you can input the sequence, and then you have to provide in the short name of your protein. It could be any protein. Then you have to put in your email address and just click on predict. After that, you have to wait a few hours. As I said earlier, you should wait about 24 hours to 48 hours. It could take sometimes about 72 hours, some in some cases. But after that, you will receive your results on your email address, and just open the link that you receive. On the top of the page, you will find the referencing. If you utilize, please consider citing these two articles. So you can read more about them to get more information about these tools. Then you have hyperlinks that actually take directly you to your datasets. It predicts 5 trade models, and they are ranked according to the local and global assessment of that protein. It also predicts disorder prediction, domain boundary prediction, binding site prediction, and full model quality assessment results. So just click on the first hyperlink, and it will take you to the models. As you can see, the model ID it predicted, and the templates it used to predict your protein structure. It is basically incorporating the threading and homology modeling together in a very unique algorithm to predict the protein structures. Then the p-value is provided, which is in-house built-in for Int Fold, and it is not a global score. Global model parity score is provided, and it is ascending order, descending order. I apologize. So the first one should be the best model, and then the local order model is priority. If you just click on that picture, you can download this plot as well. You can download this plot in PostScript and create your own plot too. So after that, you can click on the view 3 model in 3D and download. You can refine it using V4. V4 is also a University of Reading tool or server that you can and that can actually find various patterns within the protein structure that are not properly folded or that are not properly modeled out, and to try to refold them. It would try to ascertain the issues within the protein structure and fix it. So let's just download the first model, and we will then move on from there. In the meantime, let's go to and analyze other sections. Okay, so then it will try to find out the disorder prediction, and as you can see, disorder prediction from caten BL1 gene, and it will try to provide the disorder probability score, and the higher the probability score, the more the issue there's pattern within the protein structure, as you can see over here, and over here. So that means at the 0.5 is the threshold, and any bar that actually causes that, you can see that there are disorder issues, and you can download this for your proteins. Then domain binding prediction is present. You can download this, and it will be present in the JMO. You can download, and it will be colored according to the domains. If it opens, I think there is some server issue. Let's open this up in Chimera, and we can see more information. So this is the domain that is actually present within this protein that is predicted by this tool. I think there is an issue with the server that it's not allowing us to download the structure. But anyways, so ligand binding residues are predicted, but as you can see, there are no binding residues predicted. If any prediction was made, you could find the residues and their location over here, and then you could target those for ligand interaction. And same goes for model quality assessment. You can find this score over here, and you can then utilize any server, any structure from this server for your analysis. And as you go below, you can see that all of these are in descending order, and the more you scroll down, the more lower score you could find for your protein structure prediction. And the first one should be the best model, and you should download that if you are working with your protein structure. So in this case, I'm not sure why we are not able to download. I think this okay. So the actual refresh worked. So let's just download this structure, and let's open it up within a Chimera tool. So here we go. This is our protein structure that is actually predicted by this tool, and this is how easily you could predict your protein structure from Int Fold, and it will allow you to do various other analysis as well. So that was all. I hope you understand this video. If you have any questions, you can reach us, and we will most definitely help you out. Thank you so much. Have a great day.